Hello guys, welcome back. Let's write the last recursion example, Fibonacci series. So Fibonacci series is one standard example. So this is the series, Fibonacci series 0, 1, 1, 2, 3, 5, 8. So any number you take this number. So this number is nothing but sum of two previous numbers. 1 plus 1 is 2. So if you take 13, so 13 number is derived from the sum of last two numbers, which is 8 and 5. Okay, so let's write a recursive function for this. So int, so the program is write a function which returns nth Fibonacci number, Fibonacci number. Okay, so we have to write a function, recursive function, which will return nth Fibonacci number. So int f int of nth Fibonacci number. So return for any number, any number's Fibonacci number is Fibonacci of n minus 1 plus Fibonacci of n minus 2. Right, I just explained you. So Fibonacci of this number, so this is the first Fibonacci number, second, third, fourth. So fourth Fibonacci number is nothing but Fibonacci number of 3 and Fibonacci number of 2. Okay, so this is the fifth Fibonacci number. Fifth Fibonacci number is nothing but Fibonacci number of 4 and Fibonacci number of 3. So when you add these two, you will get the fifth Fibonacci number. So likewise, so for any nth Fibonacci number, you have to return n minus Fibonacci number of n minus 1 plus Fibonacci number of n minus 2. So what are the base conditions? Without base condition, this will go for stack overflow. If n is equal to 0, whenever the n value is 0, we will return 0. Okay, so this is the 0th Fibonacci number is 0 and the first Fibonacci number is 1. Okay, so if n is equal to 1, we will return 1. Okay, so if n is equal to 0, we will return the 0th value. If n is equal to 1, we will return 1. We can merge these two conditions like this. If n is equal to 0 or n is equal to 1, return n. Fine. So this is the base condition. We can remove this. So this is the base condition and this is the recursive function. So let's try to print it. So printf %t, okay, comma Fibonacci number of 5. So this will print the fifth Fibonacci number. Let's see the output. Okay, so this is the output. So fifth Fibonacci number is 5. Let's write one more statement. So find Fibonacci number of, okay, 8. Okay, let's run this. So here is the answer. So 8th Fibonacci number is 21. Okay, so let's see the recursive diagram for f of 5. So for the fifth Fibonacci number, how the recursive tree looks like. So this is the fifth Fibonacci number. So whenever you give f is equal to 5, okay, find the fifth Fibonacci number. Fifth Fibonacci number is nothing but f of 4 plus f of 3. So for f of 4, how do you find f of 4? F of 4 is nothing but f of 3 plus f of 2. F of 3 is nothing but f of 2 plus f of 1. F of 2 is nothing but f of 1 plus f of 0. So this is how the entire recursion happens, and it will try to find out the value of f of 4 and f of 3, and it will add these two values and it will return f of 5. Okay, so this might take some milliseconds to execute for f of 5. So let's see, can we find Fibonacci number of, what is the 45th Fibonacci number? Let's try to find what is the 45th Fibonacci number. Okay, if I try to debug, okay, I will come to know the shocking facts. Okay, the answer for f of phi is calculated and the output is printed as phi, but for 45th Fibonacci number the calculation is happening and the cursor is blinking. It is waiting for the answer to be calculated and printed. Okay, and it might take around 2 seconds to calculate the answer. Sorry, it might take around 5 minutes. 5 minutes to calculate what is the answer for f of 45. So why is this taking lot of time to calculate f of 45? Okay, as the n value increases, time taken to calculate the answer will also increase. As the f of 5 and f of 8 are very small values, we got the answer in milliseconds. Okay, but as the n increases, time to find the answer increases exponentially. So to calculate f of 45, it will take around 45 minutes for the computer to find the answer. Why this will take lot of time? Okay, so why? So let's understand the previous recursion tree to get some sense why it takes a lot of time as an increases. So repetition. So as you see, to find f of 5, you have to calculate f of 4 plus f of 3. To calculate f of 4, you have to calculate f of 3 plus f of 2. For f of 3, you have to calculate f of 2 and f of 1. And for f of 2, f of 1 and f of 0. So here, to calculate f of 2, okay, you are calculating f of 2 3 times. Right? Here you are calculating f of 2, here you are calculating f of 2, here you are calculating f of 2. And again, you are calculating f of 3 2 times. Here you are calculating f of 3 and here also you are calculating f of 3. Here you are calculating f of 3 2 times. Imagine for f of 45. Okay, here the tree height is, so the height you can call it as 1 level, 2 level, 3 level. Okay, f of 3 height is 3, f of 2 height is 2. So the tree height for f of 2 and f of 3 is just 2 and 3 respectively. But in case of f of 45, the entire tree height and depth dimensions will vary and you never know. Okay, you might try to calculate f of 35, okay, 40 times. You might have to calculate f of 35 40 times, and within that 40 times again you have to calculate f of 33 times, like that. Okay, that exponentially it will increase the time. Okay, if you try to draw the entire tree for f of 45, you will come to understand. You are calculating the things again and again. Here you have calculated f of 2. Again you are calculating what is the answer for f of 2. Again you are calculating what is the answer for f of 2 here. For f of 3 you are calculating here. For f of 3 again you are calculating here. So repeatedly you are calculating the answer for each particular state. Right? Any recursion we will call it as state. So for state 3 you are calling 2 times, for state 2 you are calling 3 times. You never know what happens when the n value is 45. Okay, for 45 you just draw the diagram for recursive tree diagram, then you will come to know why it is taking a lot of time. Okay, so what is the solution for this? Okay, the solution is nothing but caching. Okay, you people might have heard cache in the browsers, right? So in the browsers we cache, we save the page in the memory. Okay, we save the website in the memory. So when we are loading the same page after 2 or 3 hours, instead of requesting from the server, the browser will load the page from the cache itself. So this will save time and network data, and it will quickly show the page onto the browser window. So we have to apply some caching technique for this above example so that we can get the answer for f of 45 immediately. Okay, let's see the caching solution in the next video. See you, have a nice day.